Hi everyone, welcome. So this is the chapter of acids and bases. This chapter actually is very important and simple chapter in terms of CSIR-NET. If you observe previous year question papers, in last 2 to 3 years question papers, if you observe, one 4 marks question, one 2 marks question actually frequently asking on this chapter. And very easy chapter. To get the answers in this chapter, you have to know how to eliminate the options. By eliminating the options, you have to solve the questions on acids and bases. Okay, so very easy. So I will tell you how to eliminate the options by knowing the concept in this video. So after watching this video, you don't need to study any theory, you don't need to study, you don't need to practice any questions also. We are going to practice a lot of questions on acids and bases in this video. Okay, so first of all, we before we go into depth, we have to know what is HSAB, because if you want to solve this particular question, if you just want to solve this particular question, BH3CO is more stable than BF3CO, you have to know HSAB. So HSAB, what is HSAB? Hard and soft acids and bases. Okay, so the first fundamental rule in this HSAB, you have to know hard interactions are more preferable, soft interactions are more preferable. That means, you know, acid cannot react with acid. Yes, base cannot react with base. So always you have to remember, one acid can react with base and one base can react with acid. So if you observe any compound, if you want to know the stability of that particular compound, you have to use, by using this technique HSAB, you can get to know whether that compound is stable or not. For suppose in compound we have acid and base both, right? So you have to know one fundamental rule, that hard acid and hard base, these hard interactions are more stronger, and soft interactions are more stronger, that is soft acid and soft base. Okay, so hard base is very strong, and soft acid and soft base are very strong. So hard interactions are stronger, that means the compound which is having hard interactions is stable compound, and the compound is having soft interactions is stable compound. Then how we can get to know which is hard and which is soft? So there are rules. So the first rule you have to remember like this. So this is hard, this is soft. Actually, the younger person, for suppose if you are the age of 20-25 age, that means you are small one. Okay, you are small one, that is small size person. So whenever you are small size person, you are at the age of 20 and 25, so you are the harder one compared to the elders. You are harder. So you can remember like this. That means the first point in the hard case, so which is hard, that is small size. So the first condition is small size. Small size is hard. Okay, the species which is having small size is the hard species. And whenever the small size, that means high charge. Why high charge? Because you know, whenever the charge will increase, size will decrease. Whenever charge will increase, size will decrease. That means, for suppose you take any nucleus, for suppose boron, hydrogen, like that. Okay, so whenever it has charge like plus, what happens? We know, so the size of the atom will decrease. When size decrease, that is nuclear attractions will high. So that is, whenever nuclear attractions are high, that means it is very difficult to break. So this is hard one. Okay, next one is high electronegativity. Why high electronegativity? High electronegativity. For suppose you take for suppose here fluorine is there. Okay, here nitrogen is there. Whenever you go from left to right, electronegativity will increase, size decrease. So whenever small size, that means hard one, so high electronegativity. Okay, so last one is charge density equal to charge by size. We know density, so charge density equal to charge by size. We know small size species are hard one, so size decrease, density increase. That means high charge density, because density is inversely proportional to the size, so that means high charge density. So whenever our molecule or our species having these properties, that means they are hard one. Okay, so just reverse of this are soft. That means here high size, high charge means here small charge. You have to remember only one. Okay, if you remember one, where either it is hard or soft properties, then by yourself you can remember the other one. Okay, so high electronegative, less electronegative. Okay, and here density is high, here density is low. Okay, see, I will give you one example here. For suppose CO F6 minus 3. Okay, and CO I6 minus 3. First of all, find out the charge. X minus 6 equal to minus 3. That means X equal to plus 3. Here plus 3 charge. Here plus 3 charge. Our central metal atom has plus 3 charge. Means charge is same. We cannot do anything with this. Okay. Acha. So if you observe now, here fluorine, here iodine. Here central metal atom is same. Cobalt, cobalt. So both cobalt is in plus 3 oxidation state. So now see this, fluorine and iodine. So iodine and fluorine, if you compare, so fluorine is here, chlorine, bromine, iodine. Size increase from top to bottom, size increase, and d orbitals also increases. So whenever the size increase, that means this is the soft one. So iodine is the soft one, and here fluorine is hard one, right? Okay. So cobalt is plus 3 oxidation state is very stable and highest oxidation state of cobalt. Okay, so whenever cobalt is in highest oxidation state, that means high charge, that means it is harder one. So cobalt is a harder one. So this is hard, right? So cobalt is hard. Now tell me, this is hard soft, this is hard. So hard interactions are favor, hard interactions are favor, and this is plus 3. So it will accept electrons. So this is behaving as acid and this is behaving as base. So hard acid, hard base interactions. So this is more stable than this. Okay. So by using this HSAB, you have to find out which is stable like this. Okay. So this compound, this complex is more stable than this COI6 minus 3. Okay. Next one. For suppose you take BF3 and BH3. Okay. So how you have to compare? Simple. So BF3 is here, BH3 is here. Here fluorine, here hydrogen. Fluorine and hydrogen. Okay. You have to remember one thing. Hydrogen and H minus. H and H minus. Always you have to consider as soft one. Okay. So H and H minus are soft. So here this is soft, this is hard. So comparatively BF3 is hard. Comparatively BF3 is hard. And also for suppose in periodic table H is here, fluorine is here, right? So whenever you move from left to right, size decrease. So whenever size decrease, this is the harder one. So comparatively fluorine is hard, hydrogen is soft. Hydrogen is soft. So here boron is same. So you have to compare these two only. Okay. So boron is here, left side, boron, and here nitrogen, oxygen, fluorine like this. So here it is left side. That means size is high comparatively. Okay, but still boron is very small size. So this is hard, right? Boron is comparatively small size. So this is hard, and fluorine is hard. Hydrogen is soft. So hard interactions are more favor. So BF3 is more stable than BH3. Okay. Now do this question. BH3CO is more stable than BF3CO. Here you have to talk about the reason. Okay. So what is the reason? So the first one is, what is about this CO? What is about this CO? CO is a soft base, and BH3 and BF3 are soft and hard acids respectively. Here BH3, here BF3, right? So BH3 is soft acid or not? Yes, of course. Hydrogen is soft, so this is soft acid. And BF3 hard acid, of course fluorine is hard, right? CO is soft one. CO is soft bond. CO soft bond. Because here the carbon. Okay, so this is attached with this carbon. So carbon is soft. Carbon is soft. And BH3 is soft. So this is soft interaction. Okay, because in BH3 you have to see hydrogen, this is soft. And here CO, carbon is soft. So soft interaction. So this is more stable. Okay, you have to find out like this. Next one. Now we do the questions. By doing the questions, we will get to know the concept. See, first of all, one question I'm asking here. SBF5, BRF3, BRF2 plus plus SBF6 minus. SBF6 minus. I'm asking, what is this? Actually, if you take this reaction, what is the nature of BRF3? I'm asking. What is the nature of BRF3? Observe whether it is Lewis base, Lewis acid. So here BRF3 acts as Lewis base. Lewis base. Why? Because it is giving electrons to this. H plus donor is an acid. H plus donor is an acid. Electron pair donor is a base. Electron pair donor is a base according to the Lewis concept. Electron pair donor is a base according to the Lewis concept. Here if you observe, SBF5 has been converted into SBF6 minus, means it will take electrons, it will take F minus from here. It is giving electrons, that means it is base. So this will act as Lewis base. Okay. Next question. BRF2, SBF6 plus AgBrF4 is gives rise to AgSBF6 plus 2BRF3. Which kind of reaction it is, first of all? So here if you observe, BRF2 plus SBF6 minus. Okay, and here Ag plus BRF4 minus. Okay, so if you observe here, this is solvent, this is salt. Acid plus base, which is gives rise to the salt plus solvent. So this is one kind of neutralization reaction. This is neutralization reaction. How you can identify? This is BRF3 is a solvent here. Here AgSBF6 is a salt here. Salt. So whenever you get salt plus solvent, this is neutralization reaction. Next, KF plus BRF3, which is gives rise to the K plus BRF4 minus. Yes? Okay. So what is the nature of BRF3 here? So it is taking electrons, accepting electrons. So here electron pair donor is a base, electron pair acceptor is an acid. So it is accepting F minus here, so that it is forming BRF4 minus. So the nature of this is Lewis acid. Next, 2BRF3 BRF2 plus BRF4 minus. Which kind of reaction it is? It is self-ionization. So whenever we have the solvent, so solvent is giving positive species as well as negative species. Okay, so this is ionizing, so cation is forming, anion is forming. So this is self-ionization reaction. Self-ionization reaction. Okay, so these kind of reactions might ask in the exam. Next, next important one. The question is the compound that gives a basic solution in HF. Given four options: compound that give basic solution in HF. Okay, so that is the question. Okay, so the first one is AsF5 that will give a basic solution in HF. We know what is the basic solution. The species which can give electron pair donor is a base. Yes. First option, if I see AsF5 plus 2 moles of HF. So in this reaction, this AsF5 always acts as acid, so it will take electrons from here. So F minus it is taken. So the product is AsF6 minus and H2F plus. And H2F plus is very stable compound because it will form hydrogen bonding with another HF. If you take another HF, so it will form hydrogen bonding with this. So this H2F plus is very stable, and this will act as Lewis acid. Okay, so this will not give a basic solution. Okay, next PF5. Next option is PF5, and if it is react with HF, it will give again same thing, PF5. Empty orbitals are there here, so it will take F minus. So the compound is forming here PF6 minus and H2F plus. Okay, next option BF3, Lewis acid. Obviously we know this, 2HF here, BF4 minus plus H2F plus. So always H2F plus is more stable. But in this case, whenever I have BrF3, it is reacting with HF. In this case, this BrF3 is not that Lewis acid. Okay, so in this case, it will take it will give F minus. That means electron pair donor. So here this is the special case you have to remember. So BrF2 plus HF2 minus. So in this case only it is forming HF2 minus. In remaining cases it will form H2F plus, because H2F plus is forming hydrogen bond. So whenever it is giving its electrons, that means it is behaving as base. So this compound give basic solution in HF. So answer is BrF3. Right? Next. Next question. So one matching is given. So you have to tell the nature. Some molecules and their properties in liquid ammonia are given in column. You have to match this. So first of all, Cl2, S8, CH3, COOH, and urea, NH2, CO, NH2. This is urea. So the first option is weak acid, second strong acid, third one disproportionation, fourth one is solvolysis and disproportionation. So I have to know what is the correct option. Okay, if you observe here, first of all you take Cl2. Okay, you take this Cl2. This is actually will show solvolysis and disproportionation of Cl2 in ammonia. Why? See, the reaction is Cl2 if you take ammonia solvent, you have to remember this reaction, otherwise just try to remember, otherwise you can go through the elimination of options. So it's the first option I'm telling here. So the reaction will form NH2Cl and here HCl in the first case, right? Here NH3 you have to write like NH2Cl plus HCl. Now this HCl again react with ammonia to give NH4 plus Cl minus. Okay, so this is zero oxidation state. Disproportionation means oxidation and reduction simultaneously, right? So here -1, okay, and here this is +1, right? So oxidation and reduction simultaneously, so this is disproportionation reaction. Solvolysis means if the solvent will break, then that is solvolysis. Yes, so here NH3 solvent, here it is breaking NH2 and H, so this is solvolysis reaction. So the first one is Cl2 is 4, that is solvolysis and disproportionation. Next, S8, it is undergo disproportionation again in liquid ammonia. Okay, so the option S8 is 3, that is disproportionation reaction. So here the reaction is S8 plus ammonia, 16 ammonia. If you balance this, then you will get S4N minus, S6 minus plus 12 NH4 plus. You don't need to remember this. Okay, you don't need to remember this. So just leave this and go with the other one, CH3COOH. So for suppose you take ammonia solvent, right? Not for suppose, actually given ammonia solvent in question. So here CH3COOH acid. When CH3COOH react with ammonia, what happens? This ammonia acts as base because it has lone pair. It will take H plus, so NH4 plus will form, plus CH3 COO minus, CH3 COO minus, okay, CH3 COO minus. So ammonia, if you see ammonia, so ammonia is taking this H plus, so it will act as base. It will act as base. Okay, right. Last one, molecules. If you see this one, NH2 CO NH2, right? So it is reacting with ammonia. What happens? This ammonia, if take this hydrogen, it will give minus here. So this minus can be stabilized by this resonance, so that this will take this hydrogen, so it will act as base. Okay, it will act as base. It is giving this H plus. H plus donor is an acid, so it will behave as acid. Okay, it will behave as acid. Okay, now the answer. What is the answer? Okay, so first of all, if you see this, yeah, just wait. See, this is stronger acid, this is weaker acid. Why? Because here we have heteroatoms. So generally heteroatoms will behave as base, but whenever we are reacting with ammonia, whenever ammonia take this H plus, this conjugate base will stabilize, so that in this case it will act as acid. It will act as acid, but actually it has the nature of base, so it will act as weak acid. Okay, it will act as weak acid, CH3COOH, strong acid. So by eliminating the options, you can do this question like this. Okay, next. Next important question. For the reaction HX aqueous plus H2O is in equilibrium with H3O plus X minus. Question is the highest value of X minus concentration when X minus is. Okay, so given this reaction and given the options, you have to tell the correct option. Okay, right. Here in the options, if you see, HCl option is there. Okay, so among all 4 options, I will tell you what are the options. Just wait. So the first option is OCl minus, second option is F minus, third option is Cl minus, fourth option is NO2 minus. Okay, so the value of X minus, so these are the X values given in options. These are the X values given in options. In place of X, if I take Cl, then I will get HCl. I will get HCl. So among these all, actually HCl is actually strong acid. Okay, it will undergo more ionization, right? So hence concentration of Cl minus will be maximum. Okay, among these all, if you put Cl, this is more acidic. So that's why this will increase the concentration. Here Cl minus will form. So that the answer is Cl minus. Next. Next one. Just wait. Okay. Just wait. For suppose, where is the question? NOCl plus. I think question has been missed here. Just wait a minute. Okay. So the question is NOCl plus SM N2O4. Okay. We will do this question later. Just wait. We do other question. Wait a minute. Okay. Next question is the correct order of increasing Bronsted acidity for boron hydrates. Acidity of boron hydrates, the first structure given, that is B5H9, next one B6H10, next B10H40. Among these 3, which is more acidic? Simple, you have to remember, if number of boron atoms increase, okay, if you have different structures, on increasing the number of boron atoms, acidity will increase. Okay, so which is more acidic? This is more acidic, this is less acidic. So order is this. This is the acidity order. Okay, next one. Next question. Just wait. Yeah. Among KF, SNF4, SBF5, solutes, in these solutes that increase the concentration of BRF4 minus in BRF3. BRF3 is Okay, so which species will increase the concentration of BrF4 minus in BrF3? Very, very simple. First of all, I'm just doing reaction KF with BrF3. KF with BrF3. I will get K plus BrF4 minus. Okay, next. For suppose if I take SnF4 plus BrF3, what will happen? What will happen? This SnF4 is more Lewis acid, it will take F minus. So SnF6 minus 2 plus BrF2 plus BrF2 plus BrF2 plus SnF6 minus. Next, SbF5 also acts as Lewis acid because strong acid. BrF3, okay, it will take F minus SbF6 minus plus BrF2 plus. Yes, okay. If you observe here, in these three reactions, only KF increase the concentration of this BrF4 minus with BrF3, because in all the cases BrF3 has been converted into BrF2 plus. Means here the concentration will decrease. Here the F minus concentration will decrease. But here BrF3 has been converted into BrF4 minus. So the option is this. Okay. Next. Next one is wait a minute. Next important question. Here given 2H2O, water plays different roles in the following reactions. So the first reaction given 2H2O plus calcium, here calcium plus 2 plus 2OH minus plus H2. Okay. Second reaction NH2O plus Cl H2O N types. Okay. Next, third reaction 6H2O plus Mg plus 2 Mg H2O 6 times plus 2. Last reaction 2H2O plus 2F2, which is gives rise to 4HF plus O2. Okay, right. So which is oxidant and which is reductant, you have to tell. For suppose if you see here oxygen -2, right? So if you calculate the oxidation state, hydrogen is in +1, oxygen is -2. Yes, calcium 0 oxidation state. Okay, and here calcium +2 oxidation state. Here oxygen -2 oxidation state and hydrogen +1 oxidation state. Hydrogen +1 oxidation state, and here H2 0 oxidation state. If you clearly observe H2 +1, H2 0, that means what happens? Oxidation number decreases. That means this one is reduction. If you take water species, that is reduction. Okay, so whenever it is reduction, water is reducing here. That means whenever it is reducing, this will behave as oxidant. Reverse, so oxidant. So this will behave as oxidant. In the first reaction, H2O behaves as oxidant. Next one. Next important thing, If you take this reaction H2O Cl minus Cl H2O n times. Here if you observe chlorine, chlorine acts as a base and H2O always acts as acid. Okay, so chlorine always acts as a base. Water comparatively it is good acid, so it will form this reaction. Next, so in this reaction, what is the role of water? So here MgH2O 6 times plus 2, MgH2O 6 times plus 2, here magnesium, here ligands are there, here ligands are there, OH2, OH2, OH2 total like this, 6 ligands are there. Okay, OH2, 6 ligands are there. So ligands are donating electrons to the metal. So whenever these are giving electrons, electron pair donor is a base. So water acts as base here. Water acts as base. Next one, last one. Again, see oxidation state. Here plus 1, here minus 2. Here it is 0. Here plus 1. Here minus 1. Here 0. Okay. So observe oxidation states. Here oxygen minus 2. Here O2 0. That means oxidation number increases. Oxidation. So whenever it is undergoing oxidation, that means reverse, reductant, reductant. So water behaves as reductant. That's all. Okay. Next. Next important question. Just wait. Okay. Oxidation in acid. So action of H2O2. The first one is action of H2O2. This is matching. Action of H2O2 and type of reaction. Type of reaction. So the first one is oxidation in acid. Oxidation in acid. Here FeCN 6 times minus 3 to FeCN 6 times minus 4. Okay. Second option, oxidation in base. Oxidation in base. FeCN 6 times minus 4 to FeCN 6 times minus 3. Okay. Next option, third one, reduction in acid. Reduction in acid. Reduction in acid. MnO4 minus Mn plus 2. Last one, reduction in base. Reduction in base. Mn plus 2 to Mn plus 4. Okay, you have to match these things. First of all, clearly observe one thing. You can easily do this question by yourself. Which is oxidation, which is reduction? Here Mn plus 2, here Mn, I think last one is Mn plus 4, right? Just wait. Mn plus 4. Mn plus 4. So definitely last reaction is oxidation. Definitely last reaction is oxidation. Okay. So first of all, you have to just eliminate the options here. You don't need to know about the reactions. Okay. Here Mn plus 2, Mn plus 4. That is oxidation. Here oxidation is there. Here oxidation is there. Oxidation, oxidation. Okay. So this is the first one. This is second. This is third. This is fourth. Here x minus 8 equal to minus 1. That means x minus 8 equal to minus 1. So minus 1 plus 8 plus 7. Here plus 2. This is reduction. Okay, this is reduction. This is oxidation. This is oxidation. Okay. Here x minus 6 equal to minus 4 plus 2. Here x minus 6 equal to minus 3 plus 3. Here x minus 6 equal to minus 3 plus 3. Here x minus 6 equal to minus 4 plus 2. Here oxidation number increases. This is also oxidation. Here plus 2 to plus 3, reduction. Okay. Oxidation in acid, oxidation in base. Okay. So these two reactions are oxidation reactions. These two reactions are oxidation reactions. You have to remember one thing. Whenever we have the manganese, this oxidation will occur in acid. So definitely oxidation in acid is D. Option D. So whenever it is D, definitely next oxidation is this. Oxidation in base. Okay. Next one is, if you observe this reduction, this is acid. Again ferrous. Here ferrous. This is manganese, MnO4 minus. MnO4 minus, whenever the reduction happens in MnO4 minus, always it will take in base. So this is base, this is acid. Okay. Next important thing, next important question. Just wait. You have to remember some points here. If I take CH3 COOH plus pyridine, that is C5H5N, what happens? This lone pair will take this H plus, will take this H plus, then I will get H here, positive here, CH3 COO minus, CH3 COO minus, and C5H5 and H plus. That means this solvent is getting cation because positive charge. This solvent is getting positive charge. That means this is solvo cation. This is solvo cation. Okay. Next, for suppose same CH3COOH when reacting with H2SO4. H2SO4. What happens? It will give H plus. This oxygen lone pair take this H plus. So CH3 COO H2 plus plus HSO4 minus. Okay, this solvent is becoming anion. That means this one is solvent anion. Solvent anion. Okay. Next, for suppose if I take HClO4, this is the amphoteric one. HClO4 when reacting with H2SO4 sulfuric acid, then this ClO4 minus and H3SO4 plus. Okay, that means it is giving H plus. So this will behave as acid, this will behave as base. Okay, in between these two. Now, if you see here, this is the solvent is becoming its cation. So this is weak acid. Weak acid and solvo cation. Solvo cation. Next, SBF5 plus HF. What happens? What happens? HF is there. It will give F minus to this. Okay, SBF6 minus. Why? SBF5 is Lewis acid. Okay, plus H plus. Now this H plus again react with HF to give H2F plus. This one is very stable due to hydrogen bond. Due to hydrogen bond. Next, the least basic among the following least basic among. So the first option is AlOH twice, next LaOH twice, next CeOH twice, next LuOH twice. This is transition element, this is transition element, this is also transition element. Comparatively, here aluminum main group element, and this is in amphoteric in nature. Amphoteric means acid and base. It will behave as acid and it will behave as base, depends upon the medium. Remaining lanthanides, lanthanum hydroxides, lanthanide hydroxide, cerium hydroxide, lutetium hydroxides. So these are F block. Okay, so these all are bases. Okay, but this will behave as acid and base both. So this is least basic. This is least basic. These three are completely basic. Completely basic. That's all. Okay, so these are the important points actually. I think these are enough. I don't have much time to discuss more points, but I hope these points are more than enough. Okay, try to revise these points, try to observe these points, and if any question will come, by using these concepts, try to eliminate the options. Okay, so that is more than enough. Okay, so that's all. Thank you so much for watching.